Welcome dear students. In this video I am going to explain one of the fundamental principle of nature. That means I am going to explain law of conservation of energy or principle of conservation of energy. According to this principle, the total energy in an isolated system always remains constant. Or we can say, energy can neither be created nor be destroyed. It can be only change its form from one form to another form. Let us see the conservation of mechanical energy of a freely falling body. For this, we will consider a body of mass small m at a point A at rest, and it is at a height h from the surface of earth. So this height is h. Let this body falls freely under the gravity. During its free fall, it passes a point B after traveling a distance x and then finally hits the ground at point C. So, we will calculate the mechanical energy, that is the sum of kinetic and potential energy at point A, B and C. Let us see what will happen. At point A, if we are finding the mechanical energy, so first let us find the potential energy. Potential energy is equals to mgh. M is the mass of the body, g is the acceleration due to gravity, and h is the height. If we will calculate kinetic energy is equals to 1 by 2 mv a square. A I have written, that means velocity at point A. As the body is at rest, so its VA is equals to 0. That's why kinetic energy is 0. Therefore, total mechanical energy at A is equals to, we will get it as potential energy plus kinetic energy. So, potential energy mgh and kinetic energy is 0. So total mechanical energy at point A is mgh. If we will calculate the mechanical energy at point B, see what is the total value of mechanical energy at point B. So at point B, potential energy, so as we know mg and height h, so this height, as the total height is h and this is x, so BC will be h minus x, so height will be h minus x, and we can write mgh multiplying minus mgx. So this is potential energy. And if we will find kinetic energy, then we can write 1 by 2 mvb square. As the body falls freely, so it will acquire some velocity at point B. So let us find it using the equation of motion. V square is equals to u square plus 2as. So we can write b square is equals to 0 square. Why 0? Initial velocity at A 0 plus 2g and distance traveled this much only, so x. So we can write Vb square is equals to 2gx. So this is the velocity. Or we can write here 1 by 2 m into 2gx. This and this will cancel and we will get mgx. This is kinetic energy. Therefore, total mechanical energy at B, if we will find, then we will again find potential energy plus kinetic energy. So potential energy is this one, mgh minus mgx, and we find kinetic energy, that is mgx. These two will get cancelled and we will get mgh. So this is energy at point B. We have just observed here total mechanical energy at A equals to total mechanical energy at B, both having same mechanical energy. Now let us check what is the value of mechanical energy at C. So let us find at point C. If I will check at point C, then C is on the ground. So it means the height is 0. So we can write potential energy mg, height is 0, that's why 0. Kinetic energy 1 by 2 mv square. Again using the equation of motion, v square is equals to u square plus 2as. So we can write it as vc square is equals to u value is, again we will take 0 at point A, plus 2gh total distance. So vc is equals to 2vc square is equals to 2gh. 1 by 2 m, putting the value of vc square, 2gh. So these two is get cancelled and we get mgh. So we have just seen before this the energy at A was mgh, at B also mgh, and at C also mgh. It means the total mechanical energy remains constant during the free fall. Now we will see the variation of kinetic energy and potential energy during the free fall under gravity. So this variation we can observe through a graph. So let us see how. First we will just take two axes. This is the y-axis and another axis, that is x-axis. This is the along x-axis we are representing the height. So 0 height, that means surface of earth, and their h point means h height. In this side we will represent potential energy and kinetic energy, this side. So what we observed, at 0 height the body possesses kinetic energy, potential energy is 0. So potential energy is 0 and body is possessing only potential energy maximum, that means no kinetic energy was at point A. So we can just represent this by a graph like potential energy, means at 0 height potential energy is 0, at h height potential energy is maximum. So this is representing the potential energy. If we will observe its kinetic energy, so we have just seen the kinetic energy at maximum height was 0 and at 0 height, that means at point C, maximum. So we can represent this by another graph, and that is this graph. So this is representing the kinetic energy. If we will see this line is representing the total energy, that is mgh, which always remains constant. If we will go in the middle, that means the middle of that means h by 2 height, then the potential energy and kinetic energy will become mgh by 2. So this is all about the variation. At the if height is h by 2, then potential energy will become half. That means in the midway it having potential and kinetic energy both equal, mgh by 2. So this is all about conservation of mechanical energy when a body falls freely. Similarly, we can see conservation of energy during the motion of a simple pendulum. So let us see the energy conservation in a simple pendulum. I am talking about conservation of energy in a simple pendulum. Conservation of mechanical energy only, energy in a simple pendulum. So for this we will just see, let a rigid support and a pendulum, let this point is S, fixed rigid support, fixed point, and O. So OS is the mean position. Initially the pendulum is at rest. Now we will displace this pendulum from its mean position and we will take it to one of the extreme position. Suppose we have taken till point A. If we will take it till point A, displaced till this distance A, then the body will possess some kinetic energy. Body will possess some potential energy. Why potential energy? Because there is some height. It possesses some height h, so it will having some potential energy. We have done some work in displacing the bob. That work done is stored as the potential energy at point A. We can say at one of its extreme position. When the bob is released, the bob will oscillate like this and it will reach till another side. So it will reach on the other side of the mean position. Let it reach at point B. So another mean position. So what is happening in this? When the body is displaced at one of its extreme position at point A, it is possessing now potential energy. When it is released, the height decreases, so potential energy starts changing into kinetic energy. At point O, as height is 0 again, so total potential energy get converted into kinetic energy. After then, what happens? The body again rises till certain height, so again this kinetic energy get converted into potential energy. What is happening? At its extreme position, the body is possessing its potential energy maximum. Potential energy is maximum at its extreme position, and kinetic energy is 0 at its extreme position. And in its mean position, the body possesses only its kinetic energy, that is maximum, and potential energy becomes 0. So this is also one example of conservation of energy. Thank you students. Thank you for watching.